So here's a thought. What if some of the most cutting-edge AI stuff, the really advanced things, aren't just about silicon and code?
What if they're actually built on ideas?
Yeah.
Ideas that are thousands of years old.
Exactly. Ideas that have been around forever, really.
Yeah.
Okay, let's unpack this a bit. Today, we're doing a deep dive into something fascinating. How the wisdom of the Presocratic philosophers, specifically their really radical ideas about constant change, are maybe surprisingly foundational to the AI we see now. The really robust adaptive stuff.
Yeah, and what's amazing here is how these insights, from thinkers like Heraclitus and Anaximander, they aren't just dusty old philosophy. They're almost like practical blueprints for designing AI that can actually thrive in this world that's just constantly shifting.
Right.
Understanding these old concepts, it gives you a kind of shortcut almost to grasping the core design of modern AI. It's pretty cool.
And guiding us through this is this fantastic collection of excerpts we've found. They directly link pre-Socratic thinking to AI development. We're talking insights from folks like Jobin, Vadinsky, Vernon and Furlong, Bechtel, Langen. It's quite the lineup.
Like finding an ancient map that points to the future.
Totally. So, okay, to really get today's AI, we need to rewind way back. Back to thinkers grappling with reality itself, long before computers were even a glimmer. Let's start with Heraclitus. Famous for everything flows, right? And you can't step into the same river twice.
Right. Sounds a bit mystical, maybe.
Yeah, it can sound that way. But for AI, it's like a ground truth. His idea of flux, constant change, it's not just poetry. He saw it as the basic condition of everything. And that directly explains why AI systems have to be adaptive. They need it baked in.
Processing data in real time, constantly adjusting.
Exactly. Because for Heraclitus, understanding itself is tied to change. So if understanding is always reevaluating, does that mean the goal for AI isn't, like, static perfection?
But maybe perfect adaptability.
Yeah. That's a huge shift in how we even think about intelligence, isn't it?
It absolutely is. If understanding is about the process, not just the facts, then yeah, AI is less like a library and more like, well, a river. And then you've got Anaximander, right alongside Heraclitus, with his idea of the apeiron.
The apeiron, the boundless, the indefinite.
Exactly. And it wasn't just some abstract concept. It represented the unpredictable, the unknown, even the unknowable stuff coming at us from the world.
Okay, so like the fire hose of data AI deals with every second.
Precisely. That wild, messy, chaotic input. And Anaximander's apeiron speaks directly to why AI needs to cope with that uncertainty. And when you look at modern AI, adaptive learning algorithms, dynamic feedback loops.
That constant stream of data.
Yeah, like Vernon and Furlong point out, it's these pre-Socratic ideas staring right back at us.
It really is kind of mind-blowing how relevant they are. But here's where it gets even more interesting for me. While they talked all about change, flux, they also worried about stability, didn't they? It wasn't just pure chaos.
That's the paradox.
Right. How do you build something intelligent, something stable, when its whole environment is constantly flowing? That's a core problem AI has to solve.
And modern cognitive architectures, they try to tackle exactly that. They aim to keep the core systems running smoothly, even while they're being reshaped by new data, new challenges.
So maintaining balance,
Yeah,
preventing performance drops during adaptation.
exactly. And this is where AI kind of resolves that pre-Socratic paradox. There's this idea that processes are fundamental, maybe more fundamental than static things.
Processes, not just entities.
Yeah. Okay. So AI can continually tweak its parameters, its settings, based on new info. But the core processes, the fundamental ways it works, can stay fixed to do their main job.
Ah, so it's like permanence within the flux, order amidst the change, those old ideas again.
You got it. For these kinds of AI systems, change isn't some external shock it has to recover from.
It's just part of how it works.
It's an inherent property, built in.
Okay, can we make that a bit more concrete, like examples?
Sure. Think about reinforcement learning. That's basically AI learning by trial and error, right? Getting rewards for good moves.
Like training a dog, sort of?
Kinda, yeah. It's constantly updating its strategy based on what works, what doesn't in new situations. But its main goal, say, winning a game doesn't change. The strategy adapts. The goal remains.
Okay, that makes sense. What else?
Or self-modifying neural networks. These are really cool. Imagine an AI that can literally rewire itself as it learns.
Without a human stepping in?
Right. Optimizing itself based on new knowledge, but doing it in a way that doesn't mess up its original purpose. As Vadinsky puts it, change isn't a bug, it's a feature.
Change as a feature. I like that.
And this thinking, It points to a really major shift in AI overall, this move towards continuous learning.
Right, because the old way was static models. You built it, you deployed it, and that was kind of it.
Exactly. If the world changed, the model became outdated, brittle. But now, most AI systems are built with online learning, retraining. They're designed to keep evolving.
You see that so clearly with generative AI, don't you? Like ChatGPT or image generators?
Absolutely. They're constantly learning from user prompts, from new data they're fed. They're not static encyclopedias.
And researchers see this continuous adaptation as, well, not just nice to have, but essential, right? Crucial for AI to actually work well in the real world.
Definitely. Prioritizing adaptation to changing conditions is seen as key. Now, handling this balancing act, stability versus transformation, that's where hybrid AI systems come in. These are really interesting.
Hybrid, meaning they mix different approaches.
Yeah. They combine symbolic AI, that's the stuff based on explicit rules, logic reasoning, with connectionist methods like neural networks, which are great at learning patterns from data, more like intuition.
So logic meets experience.
Kind of, yeah. And the goal is to get the best of both, to handle the dynamic, messy environment and the need for the AI to be stable, but also transformational.
So they can cope with lots of variability, but you can still understand how they're reasoning, at least partly, because of the symbolic part.
Exactly. Interpretability is a big goal there. A good example is an architecture called Clarion, developed by Ron Sun.
Clarion, what does it do?
It's designed to actually let the system turn explicit, rule-based knowledge into something more like implicit experiential knowledge, and vice versa.
So rules can become gut feelings, and gut feelings can inform rules.
In a way, yes. It allows interaction between symbolic reasoning and experiential learning. And this directly mirrors that Presocratic idea that, real understanding needs both the permanent, stable qualities and the constantly changing ones.
You need both sides of the coin.
You really do. And this complexity leads to another challenge.
Yeah.
How do you manage all the different levels of detail?
Granularity and abstraction, you mean, like zooming in and zooming out.
Precisely. The Presocratics sort of thought about reality having different layers, accessible at different levels. Hybrid AI models try to do this too, managing different levels of granularity and abstraction.
So they can focus on the big picture or the tiny details as needed?
Right. And systems that can manage these levels well are just more effective. They handle that tension between order and chaos better.
That makes sense. By combining the symbolic and the connectionist, you get explicit reasoning and that ability to generalize from experience. Makes complex stuff easier to handle, more flexible overall.
Definitely increases flexibility. And sometimes the best way to figure out how to build these adaptive systems is to look at, well, biology.
Nature's own adaptive system.
Exactly.
Yep.
Because if you want adaptability, biological organisms are the undisputed champions, right?
Can't argue with that.
So, shifting gears a bit, it's not just philosophy. Actual biological mechanics give us clues. William Bechdel's work on circadian rhythms in fruit flies. Drosophila is a great example.
Fruit fly clocks, how does that connect?
Well, his analysis shows why we need to think about AI systems not just as static blueprints, but as structures with dynamics, how they actually respond and change over time, reacting to inputs.
Okay, so it's about the internal workings.
Yeah. Think about how your own body clock works. You have these internal feedback loops, proteins increasing and decreasing in cycles that maintain the rhythm, but also adjust to things like daylight.
Negative and positive feedback, keeping things stable but responsive.
Exactly. And that points to a need for AI to have similar internal adjustment mechanisms, not just rely on humans tweaking things constantly.
So what for AI is build systems that can regulate themselves better, correct errors, sync up with the outside world automatically.
That's the goal.
Mhm.
Understanding these biological mechanisms could help us build AI that's more robust, more self-sufficient, like these natural systems.
But didn't Bechtel also find a challenge there? Something about parameters?
Ah, yes. A key point. Those biological oscillations, they work, but often only within a really narrow range of conditions, specific parameters.
Which is tricky for AI because we want it to work in all sorts of changing conditions, right? Not just a narrow band.
Exactly. It raises a really important question. Why do we need deep causal explanations, not just spotting trends? You can't just observe that the fly clock works. You need to know how and why down to the mechanics to build something truly adaptable.
Understanding the why behind the what.
Precisely. Which brings us to another interesting concept. Chris Langan's idea of syntophiasis.
Syntophianesis sounds complex.
The core idea is actually pretty intuitive. It's about recognizing difference within sameness.
Okay. Like how?
Think about it. For AI to work in the real world, it needs to generalize. See similarities, like recognize that different breeds are all dogs.
Right. Categorization.
But it also needs specificity. It needs to see the crucial differences between those dogs or between different situations to act appropriately. It can't treat everything the same or it loses context.
Ah, so it's seeing both the category, sameness, and the individual details difference at the same time. That's vital for adapting.
Crucial. Otherwise, it can't generalize effectively or act specifically when needed. Langan connects this to his broader model, the CTMU2.
The cognitive theoretic model of the universe.
Right, which tries to unify mind and reality, the abstract and the concrete. And that effort reflects the same kind of balancing act the Presocratics were doing, trying to combine opposites.
And you see that same balancing act again in hybrid AI, right? Combining the explicit symbolic stuff with the implicit connectionist learning.
Exactly. You need both for real intelligence. You need the interpretability from symbolic logic, and you need the adaptability from experiential connectionist learning.
The goal being dynamic learning, where logic informs experience and experience refines logic.
Yes, a constant feedback loop. Logical inference shapes how the system learns from experience, and that experience then updates the logical rules. It's all geared towards smarter interaction with the changing world.
When you put it all together like this, it really highlights what a massive shift AI has undergone, a real paradigm shift.
Totally. Think back to the early days, expert systems, for example.
Right, very rule-based. If X, then Y.
And incredibly rigid. They worked fine as long as the world matched their pre-programmed rules exactly. But if something changed, if new information came along,
They broke, they were brittle, they couldn't handle dynamic info or that concept drift idea, where the data itself changes meaning over time.
nope. They couldn't learn from change. They were stuck, built for situations they were explicitly programmed for. And that was it. Needed constant human updates.
Fixed models trying to operate in a totally fluid world, it was never going to be enough.
But compare that to now. Modern AI actively integrates continuous learning, continuous updating. It's designed to handle variability.
Directly reflecting those ancient pre-Socratic principles we started with: flux, change, adaptation. It's gone from trying to take a perfect snapshot to, like, building a system that can constantly redraw its own map.
Beautifully put. Yeah. So if you zoom out, connect it all up, the philosophical questions the Presocratics were asking about change, about stability, about reality itself, they provide this incredibly deep historical conceptual foundation for how we're designing intelligent systems right now. It's uncanny.
They were wrestling with the same core problems, just millennia earlier and without silicon.
Exactly.
It's just, yeah, it's astonishing. Cognitive AI has made this huge leap from rigid, static models to actually embracing change, making it a core feature. And the goal now is technology that's more robust, hopefully more ethical, definitely more context-aware. So, okay, what does this all mean for you listening right now? Well, considering how deeply ancient philosophy seems to be baked into our most advanced tech, it makes you wonder, doesn't it? What other fields, maybe ones that seem totally unrelated, might hold keys to future breakthroughs? Or maybe just help us navigate our own lives in this constantly changing world a little bit, or something to think about.